Okay, so here's a carbonyl reaction. Um, it starts off using the primary amine, which it reacts, which upon heat, this is heat. Upon heat, chloroform, and in the presence of potassium hydroxide solution, we get our alkane isonitrile right here. And I heard that this is a very, it smells a lot, but just on the side. But anyways, the first thing that happens is we already know that our primary amine is a nucleophile. We know that the lone pair on the nitrogen is what it's gonna be the first thing that makes the attack. Alright, so we already know that we have our nucleophile. What we want is an electrophile. Looking at this, we really don't have an electrophile. So the first thing that happens is an alpha elimination of the chloroform. So we have our chloroform. See. This is our chloroform. It's the CHCl3 right here. And potassium hydroxide in solution dissociates into K plus and OH minus, right? We know that. So it's a OH minus that is what will attack the hydrogen. Giving carbon, it's negative charge, so we're going to have C, Cl, Cl. We have our negative charge. This is called our carbene ion. It's not really stable because you can't have a negative charge on a carbon. That's never stable. So what happens because of this is, in order to alleviate that instability, the chlorine will leave so that we can have two lone pairs on the carbon. So what we will have now is our carbene. Now, carbene acts as a nucleophile, electrophile. It's it can act as either or. But since in this reaction we already have a nucleophile, our carbene is going to be the electrophile. So let's start with our mechanism. Here we have primary amine. We have our dichlorocarbene. It's going to make the first attack on the carbon. We're going to have a negative charge here because again, we have 3 bonds to carbon, and now we have 4 bonds to nitrogen, so it's a positive charge. Here, what happens here is actually an OH minus comes in and it takes away the hydrogen to create the water, and it will alleviate the positive charge on the nitrogen. And on the next step, the same water molecule, the negative charge picks up a hydrogen from the water molecule. But just to make it easier to understand, what I will do here is this negative charge will take the hydrogen, which will alleviate the positive charge on the nitrogen, correct? So then what we'll have is nitrogen will be stable now. It won't have a positive charge. Cl, Cl, and we have now our H here. So now carbon has 4 bonds, so there's no need to put a negative charge on carbon. Then our next step, what we'll have is, don't forget the lone pairs. Next step, now we want to form at the end a triple bond right here, right? We want to form a triple cyanide right here. So we're going to have to do this 3 times. The first time we're going to form a double bond here. And our chlorine is very electronegative. It'll easily leave. It's a good leaving group. Our chlorine will leave. Again, we have a positive charge on the nitrogen. So again, what we will do, this time we can show the OH minus coming to pick up the hydrogen to alleviate the positive charge on nitrogen. And we will have HCl. So one more time, we're going to have to repeat this, is to form the triple bond. Again, we have a good leaving group. Chlorine will leave. Now our nitrogen has 3 bonds, positive charge, 4 bonds, sorry. Carbon still has a H. However, this is not stable. You can't have a positive charge and not have a negative charge anyway. This is not a stable complex. So we want to make it neutral. So just to show that, we will show the OH minus picking up the hydrogen, giving this a negative charge. So our final answer is this. This is what we wanted. We wanted this alkane isonitrile. And that's it.